Therefore, if we're looking at the precentral gyrus, which is this, we said the precentral gyrus is for primary somatic motor area. So to initiate movement of the hand, we said the hand is in this area here, and then the head is here. The hand information comes from the hand, from this area of the cortex, of the premotor gyrus, from this area, and then goes through the internal capsule and then down the spinal cord and so forth. We'll talk about the pathways later. So that's where it would originate, the movement of the hand. If, for example, it was movement of lower limb, the leg, it would start here, because we said the leg is here, and it would go down the internal capsule and down to spinal cord and to the legs. So that's precentral gyrus, primary somatic motor area. If we're dealing with the postcentral gyrus, if we look at it from here, the postcentral gyrus, same organization, same foot, leg, lower upper trunk, hand, arm, hand, head. But here, the postcentral gyrus is involved is the primary somatic sensory area. As a result, it's not to initiate movement but to perceive sensation. For example, let's say touch. If you have touch on your arm, from the arm the sensory information would come up, go through the internal capsule, and where is touch to the arm? The arm, we said, is in this area. Foot, leg, buttocks, trunk, arm, hand, head. So it would come and then end up here, in this area. That way the brain knows, okay, there was a sensation to the arm based on where the signal ends. If there was for example, finally, if there was like, for example, a needle, a sting to your foot, a sting, painful, that sensory information would come up through the internal capsule. The foot is here, the very first part of the paracentral lobule. It would go there, plus it would go to the cingulate gyrus because sensation of pain is here. Okay? For motor, you would not have anything go from the cingulate gyrus only for sensation. Okay, so I hope you understood. The cerebellum is a structure that's located at the base, as the posterior base of the brain. We saw it was sticking out like so, and then there was the medulla. So that's the cerebellum. So this is the structure of the cerebellum. We'll start with the top view. So here, from the top view, you see that there is a lobe, 4 of them, but it's actually 2 lobes. One lobe separated by a primary fissure. So there is a primary fissure that separates the cerebellar lobe into an anterior and posterior cerebellar lobes. Okay, so you have an anterior lobe and a posterior lobe separated by a primary fissure. That's what you see from top view. So looking at it from back view, this is the back, posterior. We saw this is top view, superior view. Primary fissures, anterior lobe, posterior lobe, and this part here is the part that, because the cerebellum comes up like that, okay? Okay, it goes up. Okay, so here it is, looking at it from posterior view. It goes up like so. So this portion here is the part that sticks out. Okay, I hope you understand. And the purpose, the reason that it is shaped like this is because you will take this and, looking at it, brain from top view, see that there's 2 hemispheres. And cerebellum is shaped like this so that it fits inside this groove, like that. And then the rest will just stick out. Okay? So here, basically, if this is the posterior view of the cerebellum, then if we have the brain here, we also see the back of the brain. So the brain, one hemisphere would be like this, and the other hemisphere. This is looking at the brain from the back. Okay? So this would be the occipital lobes of the brain.